I'll be talking about our work on trust infrastructure for grassroots organizing via grounded digital annotations. This is joint work with Seny, Zach, Tarik, Amine, and John. So some grounding context here, we define grassroots organizing as a process by which people work from within marginalized communities to build collective power and affect systemic change. There's a lot of backstory here that we do not have time at all to cover, but I invite you to read Cryptography and Collective Power, where I discuss all of these topics in more detail, including historical context and also more modern movement context for the digital era. But today I'd just like to highlight a few case studies that are really grounding context for the Tigro protocol that I'll talk about today. The first is the Black Lives Matter movement. This was specifically protests in 2020. And during these protests in Philadelphia, activists noticed that there were fake protests being organized online by members of the Proud Boys posing as BLM organizers online. So folks would put up fake protests to try to get people to come out for and ambush them. And so they began to rely on pre-existing networks to vet digital content. Similarly, activists in the Sudanese revolution in 2019 used a structured vetting protocol that was a chain of trusted one-to-one contacts and crowdsourced content moderation to vet digital artifacts online. And finally, in the anti-extradition law amendment bill protest movement in Hong Kong, they used a strong digital security culture, which is a group reflex to minimize information sharing, digitizing, and retaining, and sharing only on a need-to-know basis. So to motivate our research, we asked how might we adapt the existing trust and communication protocols of grassroots organizers from physical into digital spaces without increasing the risk of surveillance, disinformation, infiltration of grassroots movements. So far, we've hit grounding context and research questions, and next some design goals, which are directly motivated from the examples I just mentioned. The first is to ground digital trust in collective physical trust. So an observation, cryptography is typically designed for authenticating individuals and individuals' devices, whereas activists operate collectively and in person. So Tigro starts with an on-the-ground key agreement, so when the parties are physically proximal, and creates a pairwise key generation and identification with respect to the server. So the server is only seeing the collective identity rather than the individual's identities. The second is vetting on a need-to-know basis. So an observation, it's difficult to assess the trustworthiness of digital artifacts privately and efficiently. Only people interacting with the artifacts need to know their comrades' opinions about those artifacts in order to make a judgment call in the moment. So Tigro is a process of labeling digital artifacts with unique identifiers and encrypting them using the pairwise keys that were generated. Only the trusted contacts who are seeing the same artifacts are going to learn their comrades' opinions on those artifacts. Next, just a high-level overview of the protocol. It's going to be rather quick. We only have 10 minutes. So at a high level, here's the grounded key agreement. Alice and Bob wish to share a key that's rooted in their physical interaction. So they can use this key to create a collective identity with respect to a third party. We model this using an authenticated proximity channel ideal functionality, where Alice and Bob both send their identifiers and the fact that they want to do a key agreement along with their locations to this functionality. And if they are within some distance delta from each other, the functionality returns a key. In practice, we can replace this, for example, with a QR code exchange and Diffie-Hellman. So this roots the digital authentication in collective presence or co-presence, and it can establish new individual identifiers for each interaction, so none of those individual identifiers are ever shared with the server. Here's how we build the encrypted annotation system from that key pair. So let's say Alice sees an event online, it's a protest, and the organizer is Eve. So we're gonna give this an identifier of TID, and Alice says maybe, no one I know can confirm the identity of Eve, proceed with caution. So this is just an example. There's a lot of different scenarios, but sticking with this. So Alice sends this annotation to the shared encrypted PO box, which is shared between Alice and Bob. And then let's say Bob comes across the same event online and wants to check and see if any of their contacts have seen the event and know who the organizer is. Bob can search that same tigro ID to the mailbox and receive Alice's annotation in return. So this is private vetting and information sharing on a need-to-know basis. It's private because you need the key to access the box, and it's need-to-know because Bob will search for Alice's annotations once they have both come into contact with the same identifier TID, and they need more context in order to interact with that artifact safely. So we don't just want Alice and Bob, we want this to be a multi-user system. So we are going to, instead of a single mailbox, have an encrypted box bank of multiple mailboxes. And that way, they can all be pairwise distributed between Alice and Bob, Alice and Charlie, and Bob and Charlie. Just a quick comparison with related work. For example, end-to-end encrypted messengers, which are very widely used for organizing. This is still an individual digital identity that you use for messaging, and it's send and receive versus put and get, which lends messengers to context collapse. So I don't know, we've all probably been in group chats where there's so many people and everybody's talking about all these different things and you can't find the information you're looking for. So there's different contexts you might need for keeping your information organized and separate, and that was one of our goals. There's blue checks and community fact-checking. This is platform dependent. It's also subject to corporate volatility, as we've seen in previous years. There's digital annotation software, so things like Third Voice, Hypothesis, and NB. To our knowledge, none of them are privacy preserving. They're also individual digital identities and mostly designed for co-working. And finally, anonymous communication protocols, which we do utilize in Tigro. These are providing anonymity, but there's no fine-grained trust. So they have a basic communication structure of send and receive and are typically public bulletins. Briefly, implementation and security. So looking at Grassroots adversaries. The first is a combination of physical and recovery adversaries. These are people on the ground, so people and devices in close physical proximity. Digital passive adversaries, who are people with devices and trying to get public information online and the networking. And we also consider the third-party host, which is the service, probably the server, who's going to try to access people's digital info. Then there's more active adversaries, such as an infiltration adversary who is on the ground and trying to pose as a legitimate participant. We do not cover this case at all. If someone has physically infiltrated, that's outside the scope of our work. But digital infiltration is where Tigro is very strong, so this would be a network adversary that tries to pose as a legitimate participant online. We have two different implementations, so I'm actually not even going to talk about the security definition because we don't have time, but there it is. And the two implementations are a medium leakage one and a subliminal leakage one. So the first one reveals the number, the timing, and the existence of operations, as well as anonymous social network graphs. If you want to hear more about that, please come talk with me. The second is a subliminal leakage version, which reveals no information beyond the existence of the structure itself. So the number, the timing, and the existence of operations are all hidden. That one's much slower. We additionally implemented a Tor layer that's either a single Tor circuit for all of the boxes, which links someone's identity across boxes potentially, or a different Tor circuit per box that they use, which is much slower, but safer in that it does not link people's boxes together. So Tigro versus Grassroots adversaries. On the ground, the adversary could learn who's talking to who. They cannot de-anonymize subsequent server requests. And assuming we're using the anonymous channel, or decrypt any communications. The network reduces to, so for example, the third-party host reduces to the leakage that I just mentioned on the previous slide. And after a ground key exchange, the adversary learns the contents of the shared box if they are physically infiltrating. So if they have gained access into the physical activist community, they're going to see whatever they're talking about and potential correlations with the host as well. And this is where we're strongest in the digital infiltration square is not applicable here because all of the legitimate digital interactions are rooted in the grounded key exchange. So that's all. Please come talk to me if you have any questions after the session.